During the following program, look for web markers like this, which lead you to expanded coverage on our website. Tonight on Nova, for centuries we fought a savage enemy and made deadly mistakes. But the ashes of tragedies past have led to better ways to escape because accidents happen. From the first fire plugs and safety codes to today's state-of-the-art weapons, modern firefighting has evolved. But can it get you out alive? Tonight, the battle against fire. Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
This program is funded in part by Northwestern Mutual Life, which has been protecting families and businesses for generations. Have you heard from the quiet company? Northwestern Mutual Life.
And by iOmega, makers of personal storage solutions for your computer, so you can create more, share more, save more, and do more of whatever it is you do. iOmega, because it's your stuff.
And by the Corporation for Public Broadcasting and viewers like you.
I've seen the nasty, horrendous aspects of fire. It's elemental. It's like an ocean, a huge ocean wave. It's the power. There's some power in it that you have to be afraid of, and you're just fooling yourself. You're just a naive, ignorant little creature, unless you respect it.
The full horror of fire can be understood only by those who escape with their lives. Time after time, the same deadly mistakes are made as victims underestimate the speed of fire. They become disoriented in thick, blinding smoke, or suffocate on choking, toxic fumes. Firefighters have battled this savage enemy for centuries, requiring an increasingly sophisticated arsenal of weapons. But the towering skyscrapers of the 20th century have outstripped even the most modern firefighting technology. Today, the best way to defeat fire is to prevent it. We expect public places we frequent to be fire safe, like London's King's Cross Station. This is the ticket hall of one of Britain's busiest travel gateways. It houses 5 subway and 3 railway lines. Today, it's outfitted with modern fire prevention technology. But it wasn't always that way. When thousands of commuters passed through King's Cross Station in November 1987, they had no idea they were in any danger. The fire started small. A careless act on the Piccadilly line escalator. One of 6 escalators in the station, it was made almost entirely of wood. Underneath, years of grease and accumulated debris ignited.
I've been to basement fires before. I've been to many large fires before. I've been to fires involving numbers of people, but nothing quite like this.
Hidden under the Piccadilly line escalator the fire continued to grow, but rush hour crowds still poured into the station. Upstairs, a young musician named Ron Lipsius found nothing out of the ordinary.
Everyone's like walking around normally. We did notice a couple of guys sort of blocking the Piccadilly escalator with their arms folded like that, just standing there like statues, really.
Blocked from the Piccadilly line escalator and unaware of the fire, Ron decided to take the nearby Victoria line. He waited on the platform for a train. Several precious minutes would go by before he was advised to leave. Nearing the top of the Victoria line escalator, Ron began to realize that something was dreadfully wrong.
All of a sudden we realized that the very spot that we had entered just 10 minutes ago had gone really nasty looking.
The fire was heating up the wood and gradually building up, and then at the right time, bang.
Suddenly, the fire bolted up the Piccadilly line escalator and exploded into the ticket hall. It was flashover, the worst possible moment in a fire, when everything combustible suddenly bursts into flame. King's Cross Station had become an underground inferno.
Temperatures are reaching something like upwards to 1,000 degrees centigrade, and there's no way of getting out of that. You can't crouch down low because the heat is everywhere.
Knocked down and badly burned, Ron somehow survived. But he was in mortal danger.
Acrid, black, thick smoke. Very shortly I was disoriented and, virtually blind.
Upstairs, the casualties were mounting.
Some people had, their clothing was alight, their hair was very singed. Where their arms and skin were exposed, there was skin hanging off that had been burnt. They were in a lot of pain and total panic.
Still downstairs and stumbling around, Ron was fighting for his life. Then the miracle, as he calls it, happened.
I was actually, without knowing it, at the very foot of this stairwell. There was this quite bright street light, like a beacon. So I just followed it. I mean, I just said, that's my exit light,
Once outside, Ron collapsed on the street and was rushed into an ambulance. He spent weeks in the hospital and years recovering from his burns. Since then, Ron's had dozens of operations to regain function in his hands. Before the fire, Ron was building a career as a guitarist. He can no longer play the guitar, but he still writes music, and he considers himself lucky. He escaped. 31 people died in one of the worst fires in British history. But why? It took months of sifting through the ruins to understand why this fire was so unusual. Hotter, faster, and more ferocious than most.
The shape of the escalator itself is like a trench that the fire went up either side. As it got near the top, the hot air and gases were rising, superheating the ceiling, which the paint became hot. As it got near the top, the flame actually curved out, came over up to the ceiling, and it wasn't long after that the actual whole escalator flashed over.
After the fire, more than 150 changes were recommended throughout Britain's public transport system. The wood escalators have been replaced with stainless steel. Underneath, the mechanisms are cleaned regularly and automatic sprinklers have been installed. Smoke and fire alarms are now in place and smoking bans are strictly enforced. All lessons learned from the tragedy at King's Cross. Throughout history, fire safety has come at a terrible cost, and every innovation is a legacy of centuries of battle against this brutal enemy. One of the first chapters in firefighting history was written 2,000 years ago in ancient Rome, where a brand new technology was in use: the pump. It remains the single most important weapon in a firefighter's arsenal. The well is filled by buckets, and the pumping action propels a continuous stream of water right into the fire, closer than any human could get. When Rome passed into history, the water pump was forgotten. And in the vast darkness of the next 1,000 years, firefighting in Europe was reduced to prayer and superstition. By the middle of the 17th century, London was wholly unprepared for the disaster it was about to experience. A fire of such magnitude, it would have consequences for centuries to come.
Like every town and city in the 17th century, London ran a dreadful risk of fire. Buildings, obviously, were of timber, lath and plaster. Many had jetties like the one like this, and so reached out across the narrow streets and alleys till they almost touched, and fire could leap across the streets. Inside the houses, you have open fires, you have tallow candles or rushes, which can easily set fire to bedclothes or to other things in the house. You've got industrial premises mixed in among houses. You've got blacksmiths, you've got goldsmiths, you've got bakeries. And in fact, it was no accident that it was a bakery where the fire began in September 1666.
Spreading to the roof and fanned by a strong wind, the fire advanced rapidly. As it moved away from the river, another of London's problems became all too apparent.
Well, what you needed was water. Thing is, in 17th century London, water's in short supply. Okay, you can get it from the Thames, but that can be 100 yards. Or you can get it from the pipes of the water companies under the cobbles.
In the dark of night, the citizen firefighters had to break through the cobblestones. With fire spreading all around them, they burrowed down to the wooden water pipes several feet below. More precious time passed while they drilled a hole in the wood. Finally, some water to fight the fire. Bucket chains were formed, sometimes hundreds of people passing leather pails from hand to hand until they reached the fire. But all too often, the water would give out. The pressure was very low, and the pipe system unfamiliar to these volunteers. Sometimes they'd cut into the wood at the wrong spots, wasting water and running upstream areas dry.
But the other thing they had were these, known as squirts. They were brought into London first in the 1620s. And as you can see, they work like a giant syringe, and they'll squirt about a gallon of water into the flames.
A pitiful defense against a raging inferno. But the biggest challenge they faced was to fight the fire where no squirt or bucket could reach.
If the fire caught in the roof, then the situation got worse. The only thing you can do is actually drag down burning tile and timber down to the street where you can extinguish it with buckets. It must be an incredibly dangerous job to actually reach up and bring down such debris rain upon the street.
London was in chaos, teeming with people desperately trying to save their possessions.
Samuel Pepys, for instance, when he saw the fire finally beginning to advance towards his house, dug a pit in his garden to put in his valuable wine, his money, his documents, and his Parmesan cheese.
Dry conditions, strong winds, and the total lack of trained firefighters conspired to keep this fire burning.
It burned for 4 days and 4 nights. Nearly 100,000 people were made homeless. It was only when the wind dropped that the fire began to burn itself out.
The Great Fire of London destroyed 3/5 of the entire metropolitan area. With their city in ruins, the people of London finally realized the only escape from the devastation of fire was to be prepared. From the ashes of London, modern firefighting began. New building codes were passed. Wood and plaster were replaced by more fire-resistant brick. Soon, a better water system went under construction. Wooden mains were still used, but now holes were pre-cut in them. Removable plugs were placed in the hole, and they were made long enough to reach above ground, marking for the next fire exactly where the water was. This is the origin of the phrase fire plug, what some people still call hydrants today. But the Great Fire might have been very different with one of these. 1,000 years after Rome fell, the Dutch reinvented the pump. While London burned, Amsterdam was protected by 60 manual pumps and hundreds of trained firefighters. But there were drawbacks. Their pumps had fixed nozzles. The best they could do was aim the water at a window and hope that it reached the fire inside. It took a 17th century Dutch painter, Jan van der Heyden, to revolutionize firefighting with an invention we all take for granted today, the hose. It was made of leather, and 50 feet of hose weighed about 100 pounds without the water. With the hose, Amsterdam's firefighters could get the water closer to the fire than was ever dreamed possible. By the mid-19th century, manual pumps had grown very large to cope with the dangerous fires of the industrial age.
The problem with these big hand pumpers is they use the crews up very rapidly. They take a lot of people. This is when the volunteer fire companies get to be like 50-man companies because you need all these bodies to keep the hand pumpers running.
Large groups of volunteer firefighters created other problems, especially in cities like Cincinnati, with competing immigrant populations.
The conflicts between those groups and society in general show up with the fire companies. For some social, ethnic, or even personal reasons, these guys just don't like each other. Somebody'd make a rude comment, and you'd start a massive riot.
The problem would be solved with the same technology that powered the industrial age, steam. A steam-powered pump could dramatically reduce the number of men needed in the fire service. In 1852, Cincinnati unveiled the first American-built steam-powered fire engine, and the firefighters didn't like it at all. Determined to get this new technology accepted, the city of Cincinnati held a public contest. The steam engine with its 3 operators would compete against their best manual pump and a dozen of the strongest firefighters. And may the best man or machine win. For the firefighters, the steamer was a serious threat.
Volunteer things like fire companies are a place where they could get a sense of belonging. They're a social institution, sometimes a political institution, and the steam engine was a threat to this.
Determined to beat the steamer, The volunteers had an early advantage. All they needed to do was connect the hose to the pumper, tap into the underground water well, and pump away. With strong backs and a determined will, they quickly got a good stream of water going. The steamer took much more time to get ready. It needed to be hot enough to generate the steam that powered the pump. But finally, it too produced a strong stream of water. At best, the contest looked like a tie. But time would catch up with the volunteers. More than 20 minutes of strenuous pumping took its toll. Exhausted, they gave up the fight. Now the steamer really showed its stuff. Not just one, but 4 streams of water, all equally strong, all from one engine, and it would pump until the coal ran out, or the water. Within a year, the city of Cincinnati would change its entire system of firefighting.
They look at Boston, which has a paid fire department, had for some time at that point. They said, this is very efficient. They have good discipline when they pay these guys. With the steam engine, we can mix these ideas together, and down in New Orleans, they're using horses to pull the apparatus. If we put together a whole package of the steam engines and horses and paid firefighters, we'll be more efficient, we'll be able to get to fires faster, we can fight them longer.
By the end of the 19th century, most cities in America and Europe were using horse-drawn steamers. Ultimately, they were replaced by motorized fire engines. This is the Cincinnati Fire Department today. It is one of the busiest in the United States. In the battle between man and fire, the goal has always been the same: to get as much water onto the fire as fast as possible. Success usually depends on the technology available. Today, the engine itself is a pump that carries hundreds of feet of hose, many ladders, and a vast array of equipment that often marks the difference between life and death.
We certainly use a lot of technology today that we didn't use years ago, and it's certainly very important for us. It's kind of like fighting a war. You know, as the war gets worse, you need better weapons, and technology, in our case, supplies those weapons.
They're even beginning to look like weapons. The Cincinnati Fire Department is testing out this quick-action water cannon that fires a fine mist at more than 300 miles an hour. No hydrant hookup is needed. The mist gun is completely self-contained. The small water tank provides enough ammunition for 35 shots, each one powered by a slug of compressed air. This gun may be most useful when water is scarce. One squirt has the same effect as 35 gallons of water from a conventional hose.
Fire is a very frightening experience. You go in and it's absolutely black. There's a lot of heat. You can't see a thing. You know the smoke is so toxic that if you take a couple whiffs, you're going to go down and not get up. A person that's not been trained or a person that's not been properly prepared to deal with that environment has very, very little chance of surviving in a hostile fire environment.
In order to survive this hostile environment and do their job, firefighters must be protected. The first line of defense, protective clothing.
Well, this is turnout gear. This is the equipment that the firefighters wear when they respond to and go to work at a fire. I've got a couple young firefighters here to help me demonstrate this stuff.
Turnout gear is designed and tested to keep the firefighter inside as cool as possible, in temperatures that can soar well over 1,000 degrees. It's also fire resistant. That's extremely important in situations like this. A firefighter caught in a sudden explosion, fuel and fire sprayed all over him. Thanks to protective clothing, he only suffered a burn on his ear.
The next thing we want to throw on is a self-contained breathing apparatus.
Without a supply of air, firefighters are unable to enter a burning building.
He may get 30 minutes, he may get a little more, a little less out of there.
Even with air, there are many dangers inside which could incapacitate firefighters. That's why they wear a device that can signal for help.
What that device is designed to do is if he were to fall down, become immobile, not be able to move for a certain length of time, that thing will go off and allow us to find him in a dark atmosphere. And we'll be, you know, we may not know where he's at, we might be able to see him, but we'll be able to hear that pass device. He can also make it operate himself. Go ahead and make it, hit the panic button, Hockey.
But perhaps the worst part about fighting a fire is the lack of visibility. These firefighters are about to test a new piece of equipment that could help them see in the smokiest environment.
Okay, now you'll notice, see how the smoke's already building up? You can see I want you down on your knees.
As the toxic cloud of smoke descends with deadly speed, everyone in this room is in mortal danger.
Work our way out.
It's the smoke that kills in most cases, not the fire. Within minutes, visibility in this room will be down to 0. This is what a fire really looks like. Unlike the movies, there is no flame lighting the way. All is obscured by black, deadly smoke. These are the conditions that firefighters walk into every day.
It's important to make sure.
But this helmet has a camera attached to the brim that can penetrate the darkness. Using thermal imaging technology, what it actually sees is heat.
Make sure you don't bring your right hand up and block that sensor. Stay low and pan the room very slowly. Look for the victim. Okay. Okay.
Once inside, this firefighter can immediately see the white-hot flames of the fire on the left.
You find a victim?
And his colleagues searching along the wall.
Timmy, where are you?
Got a victim on the couch.
But the victim is the other way, clearly visible with the helmet.
To the left, I got a victim on the couch.
To the left?
To the left, follow my voice.
He can even guide his colleagues over to help in the rescue.
Right here.
Okay.
Victim on the couch.
All right.
I got his feet.
All right, take his feet. Wait a minute, let me support the head. Tammy, take this.
A couple of decades ago, this was secret military technology that helped illuminate targets at night. Now, a life-saving device, there is one drawback. Few fire departments can afford the $25,000 price tag.
Engine 17, 24, 14, truck 6. Truck
In real emergencies, seconds can make the difference between life and death. Today, Cincinnati averages about 4 minutes from the time the alarm is called in to the moment firefighters arrive on the scene. But it wasn't always that way. Modern fire communication began with the invention of the fire alarm box in Boston in 1852. Hidden inside was a telegraph system. When the lever was pulled, The number on the box was transmitted across town to fire alarm headquarters. From there, it was sent on to the fire station nearest to the box. At the station, the address of the box was identified and the fire company was off, sliding down the newly invented fire pole. In some stations, the alarm system triggered the stall doors to open automatically, and the trained horses were harnessed within seconds. Of course, the firefighters still didn't know exactly where the fire was. If no one stayed by the alarm box, they'd just have to drive around until they saw smoke or flame. Over the years, fire alarms saved countless lives. But there was one problem some local fire departments went to great lengths to remedy.
To discourage false alarms, the Cleveland Fire Department tested a cunning contrivance that automatically manacled anyone sending an alarm. Seemed like a good idea all around, the only catch being it discouraged genuine alarms too. Who'd put his hand into that thing?
Today, Cincinnati, like cities all over the world, uses telephones and computer systems to get to the fire fast. All emergency calls in the city of Cincinnati come here first.
Cincinnati Fire Department. Yes, sir. You said you have a person on the second floor?
With Enhanced 911, the address of the telephone automatically comes up on the screen. But that's not always the address of the fire.
The address of the fire? 1200 State Avenue. Trapped on the floor. All right, sir. We'll get someone there. 1200 State.
Now the dispatcher goes to work. His computer determines which fire station is available and nearest to the fire, and the call goes out.
21, 24. Respond to a one-alarm fire at 1200 State Avenue between Wilder and Mistletoe.
It's very important that we maintain that fast response time because a lot of things can happen in that 4 minutes, and a lot of times we rescue people in this city merely by seconds.
Fire does its worst damage in the first few minutes, before most fire departments arrive at the scene. The solution to this problem is to build fire safety into buildings themselves. Like this one in New York City. In 1911, this building was a monument to fire safety. Made of stone, steel, and masonry, it was considered fireproof. It even had a rudimentary fire alarm and a water supply on every floor. When a small fire broke out on the 8th floor, everything went smoothly. The fire department arrived quickly, and the fire, confined to 2 floors, was put out within 18 minutes. It was indeed a firefighting success story, except for one thing. The building was a death trap. Gary Breeze, executive director of the International Association of Fire Chiefs, visits the building that forever changed worldwide attitudes about fire.
Here we were in 1911. There's 600 people, mostly Italian and Jewish immigrants, mostly young women between the ages of 13 and 20. And they're working and putting together what are called shirtwaists, dresses of the time. They were packed in very much like sardines. I mean, this is a classic sweatshop operation, and it was a disaster waiting to happen.
As the workers got ready to leave for the day, no one noticed a small fire smoldering in a rag bin. By the time they did, it was growing rapidly, fueled by oil from sewing machines and flammable materials.
It reaches the tissue paper patterns that are hung above the cutting tables and begins spreading quickly throughout the 8th floor. And the women that are there begin to panic and try to get through the doors.
But one of the exit doors was always locked to prevent the employees from taking breaks or stealing. There were 3 other exits. One led to a steep and dangerous staircase that was filling with smoke. It quickly became unusable.
Now, the fire escape on the back of the building is loaded with people who are trying to get down. But the fire escape's also made out of iron and was not anchored adequately to the building, and it was heated by the fire. and began melting and twisting like you would expect iron to do, and was overloaded, and it twisted and buckled and dumped all of those people 9 stories to their deaths.
All that was left were 2 tiny elevators.
The elevators were only about 4 by 5, very small elevators, designed to carry about 10 people each, maximum. And it wound up taking as many as 20 to 25 people on each trip, packing them in, crawling on top of each other. And toward the end, the last trips were made very horrendously. The people on the floor recognize that they're not going to be able to wait for the elevator to come back. And they begin jumping to the elevator cables and that, and trying to slide the cables, or in fact jumping down to try to land on the roof of the elevator. And the last load, as they came down, it was packed with people. It got to the bottom of the shaft, and the people began unloading, and bodies began hitting the top of the elevator such that it warped the elevator so badly that the framework was warped and it could not go back up again.
No stairs, no fire escape, and no elevators. The remaining Triangle Shirtwaist workers were trapped.
Imagine what it's like. You're trapped in a building, the fire's cut you off from all your exits, and the only way you have to go is to step out on a very narrow ledge outside the building and look 8 stories, 9 stories down. The fire department ladders can't reach them. People are watching this on the sidewalk. There's absolutely nothing that can be done. And suddenly the choices become pretty evident, that you either burn to death alive inside of an inferno, or you make an effort to try to jump to safety out the window. And 8 stories at that point in time, 9 stories doesn't look that high up in the air when the choices aren't very many. You had girlfriends hugging each other and jumping together. You had a man and a woman kissing and jumping. You had a group of 5 people hold hands and jump together for courage. It was an incredibly tragic sight.
146 people died in the Triangle Shirtwaist Fire. 70 more were badly injured. It all happened in less than 20 minutes.
Well, the Triangle fire caught the nation's attention. It certainly caught the fire service's attention. And we began looking at really what caused the deaths, and began looking at the building codes and why they were so inadequate to allow those people to escape. And that developed into a building exit code finally. It evolved into what's now called the Life Safety Code.
Every industrialized country has a life safety code, requirements for building design and construction that protect human life in a fire.
If you pick up the Life Safety Code, it's very similar to picking up a holy book, because almost every word and every sentence is in that book as a result of usually tens, if not hundreds, of people's deaths.
We're surrounded by the legacy of tragedies past. After a rash of apartment and hotel fires in the 1940s, fire escapes were mandated. In this century alone, thousands of people have died in theater fires. Today, most theaters are required to have numerous exits, and occupancy is strictly limited. Fire alarms and sprinklers are also required, and curtains must be made of fire-resistant materials. Sometimes, a single fire can have a profound effect. In 1942, Boston's Coconut Grove nightclub was crowded. Many of the customers were soldiers and sailors celebrating their last days before shipping out to war. Exactly how the fire started is still in question, but there is no doubt about the tragedy that ensued. The ceiling was decorated with a highly flammable fabric. Fire and toxic smoke filled the room in seconds.
We had overcrowding, poor exits, plus flammable scenery, and then panic and fire.
Hundreds of people became trapped in this burning inferno, crushed up against doors that opened inward. Other exits were completely sealed off.
The majority of the people could have gotten out, except they had a revolving door that when people got into it, it jammed up,
and there was no way to unjam the door, and the people simply piled up behind it, and people just died in droves right behind the door, within looking distance of freedom.
492 people died in less than 15 minutes. The injured lined the hallways of Boston's hospitals. Officials collected bodies for hours. Personal belongings were gathered in piles, and unclaimed cars were towed away for days. It remains the worst nightclub disaster in American history.
As a result of that fire, we readdressed exiting provisions, and you'll now go into any public building that has a revolving door, and beside it there'll be flanking doors on both sides that have direct access to the outside.
Today's cities reach to the heavens, but it's buildings like this that pose the greatest danger for the occupants and the greatest challenge to firefighters. Some of the most horrifying fires have occurred in the high-rise buildings that tower over our cities. One of the worst, the Joelmo office building in Sao Paulo, Brazil, in 1974. It started on the 15th floor. The stairwells filled quickly with smoke and flames. The heat was so intense that the helicopters could not land on the roof. Ladders could not reach the trapped victims. For some, there was no choice. 179 people died, the greatest loss of life in any high-rise fire. The firefighting challenges posed by high-rise buildings were graphically illustrated in this Philadelphia building. In 1991, a fire broke out on the 22nd floor. The only luck in this fire was that the building was empty. Everything else that could go wrong did.
Fire department responded. As soon as they got there, the power went out for the entire building. Had to begin moving all their equipment by hand up the stairwells. And when they got up to begin engaging the fire, they didn't have enough pressure in their hose. And consequently, the fire continued to grow in size.
The water pressure problem would not be solved for more than 10 hours. In that time, 3 firefighters lost their way in the smoke, ran out of air, and died.
A structural engineer advised them the fire had been burning so hot for so long that floors may begin collapsing in the building. And the fire chief made the decision, a very difficult decision, to evacuate all firefighting and stop all firefighting operations. And the fire service pulled out and literally stood on the street like a spectator would and watched the fire consume the floors from 22, 23, 24, all the way up to 30.
On the 30th floor, their luck turned. A few floors at the top had been retrofitted with sprinklers.
10 sprinkler heads on the 30th floor did what the best efforts of the Philadelphia Fire Department could not do, and that stopped the vertical progression of the fire.
There has never been a multiple death in a properly sprinklered building, yet only 40% of high-rise buildings have them, less than 2% of homes. The surprising thing is that the technology has been around for almost 200 years. Sprinklers date back to 1812, when British inventor Sir William Congreve patented the forerunner of the modern sprinkler system. He arranged a series of perforated pipes along the ceiling. Valves outside the building controlled water flow to the pipes. That meant that fire had to be big enough to attract notice. 50 years later, a piano maker would come up with the automatic sprinkler. Unaware of Congreve, Henry Parmalee long feared what a fire could do to his Connecticut piano factory. He would not only solve that problem, but create a new business for himself. Parmalee placed a cover over a small piece of pipe. The genius behind this idea was that the solder he used would melt at 155 degrees. Then he attached the assembly to a pipe that was directly connected to a water supply. To protect the entire area, he spaced a series of pipes several feet apart along the ceiling of his factory. When the temperature at the sprinkler head reached 155 degrees, the solder would melt. Although today's sprinklers are more efficient, the basic technology is still the same as Henry Parmalee's invention almost 150 years ago. Sprinklers would probably have made quick work of this 1993 fire in Basingstoke, England. But none had been installed because engineers believed this 5-year-old building would itself prevent fire from spreading.
They had good insulation on all the walls, they had pressurized staircases. The whole structure was fire blocked, which meant that if a fire started on a floor, it would be contained on that floor and it wouldn't spread to the rest of the structure.
And it worked, for a while. The fire was initially contained on the 8th floor, but there was one thing the designers didn't plan on.
Eventually the exterior glass panel broke and flames emerged from the fire compartment. What they'd forgotten to take into account in designing the structure was that it was possible for fire to spread to higher floors via the exterior portion of the building.
It was an expensive lesson that none of the building designers predicted. To understand this unusual fire, the University of Greenwich rebuilt the exterior of the Basingstoke building in its computers.
Here we have 3 segments of a view of the same structure. On the left we've got a case where we've got the fire that's broken the glass and is beginning to spread up the side of the building, and as you can see the fire plume adheres to the side of the building, and as it adheres to the side of the building it's more likely to spread fire to the upper floors and in fact to the exterior part of the building.
To solve the problem, Ed Gallia drew in some ledges or protrusions over the window. On the far right, the 1-meter ledge is big enough to deflect the flame. Although some of the hot gases cling to the building, the temperature stays low and the fire won't spread from the outside.
As far as I know, no buildings have purposely put in this device as a means to prevent fire spread to the higher floors. However, some buildings have it as a matter of course. For example, if you have a balcony, you have this protection built into your structure. Or it could be a deployable device, so that when a fire breaks out, you have a deployable ledge which comes out perpendicular to the side of the building and deflects upward moving flame.
Computer modeling holds promise for safer building design, although even Ed Gallia warns that computers can't solve all fire problems.
It's not possible to design a building which is 100% fireproof. Because of that, then you need to make sure that you can get people out of that structure as quickly and efficiently as possible.
Escape from a fire demands more than good design. It also requires understanding people. This became painfully obvious in Bradford, England, when in the middle of a televised soccer game, a small fire started in the debris under the stands.
And we've actually got a fire in the stand on the far side of the ground.
People are still sitting around watching the game, watching the fire, and not really trying to get away from it as quickly as possible.
Very soon, the heat and flames became unbearable.
One hopes the stand doesn't burn down. And the 2,500 people in that stand are panicking.
And within seconds, that small fire developed into a flashover event which took the entire stand.
These are disastrous scenes for the club.
53 people died, mostly because they waited too long to escape. But why didn't they recognize the danger?
I think most people aren't faced with fire in their everyday life. We no longer have open fires in our houses. We have central heating. We no longer have fire for cooking. We have electric cooking ranges and so on. So when a fire incident happens, they forget about how quickly fire can spread, and they've forgotten about how dangerous the actual fire products, the gases and the smoke, can be.
To save lives, human behavior must be taken into account in modern building design. And that's exactly what this computer model does. Each one of these virtual people is given physical attributes: age, weight, strength, and so on. And they are also given psychological traits: drive, intelligence, and ambition.
Well, we're using the Exodus computer model to help design structures while the building is still in the planning phase, so that it's more efficient in terms of evacuation of people. Where do you have the exits, for example? How wide should the exits be? What sort of staircases should you have? How many staircases? What sort of procedures should you have?
The goal is to learn the lesson before tragedy strikes. Maybe in the future, more fire victims will die in computers than in their homes and offices. But until then, surviving a fire involves knowledge and preparation. Gary Breeze knows better than most that no building is fireproof. For him, fire safety is a routine part of everyday life.
And your last name, sir?
Last name is Breeze, B-R-I.
Mr. Breeze, I have you here for 2 nights.
Well, when I check into a hotel, or in fact when I go in any high-rise building, I ask the front desk whether the hotel is sprinklered and detectored.
It is, definitely.
As I'm walking down the hallway, I'm looking, are the fire extinguishers there? Are they in fact in date by the sticker on the extinguishers? Are there detectors in the hall? Are there sprinklers in the hall? I mean, this doesn't take any time. It's just time you're walking down the hallway. I ask for a room no higher than the 7th floor and facing the street. And the reason is, if all things fail, most fire departments in urban cities will have ladders that will probably reach the 7th floor of the building to evacuate over a ladder if necessary. I check to see if the smoke detector's in the room, sprinklers in the room. I test the smoke detector.
The most important thing to know is where the exits are in case an emergency does happen. Gary walks the route as soon as he's settled in his room.
As I'm walking to the closest exit, I'll note how many doorways there are between myself and that exit. Because invariably, the fire alarm's going to go off and you're going to roll out of bed half asleep. You don't know where you are anyway because it's a strange hotel. I go through this procedure for my own safety. But as importantly, or maybe even more importantly, I go through it for my family. They deserve a parent who's coming home from the trip. They don't deserve a phone call in the middle of the night.
I don't trust anywhere. I don't care if it's a government building, a cinema, wherever. I don't trust anything anymore. First thing I do when I go inside a space is I think, how am I going to get out? I had a real tough time trying to get out of somewhere once, so I don't want it to happen again.
What do you need to know when accidents happen? Be prepared. Log on to NOVA's website. The Escape set is available on home video cassette for $49.95 plus shipping and handling. To order, call 1-800-255-9424. Nova is a production of WGBH Boston. Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
And by iOmega, makers of the zip drive and 100 megabyte zip disks. Your universe is expanding, but you can save it in your own personal space. iOmega, because it's your stuff.
This program is funded in part by Northwestern Mutual Life, which has been protecting families and businesses for generations. Have you heard from the Quiet Company? Northwestern Mutual Life.
And by the Corporation for Public Broadcasting and viewers like you.
This is PBS.
I watch a lot of news, but I really look for in-depth coverage. I look for balanced coverage.
I like to watch PBS.
PBS offers a banquet of programs. I like to keep informed. A lot of times I don't have time to read newspapers, and I've watched a lot of the different channels, but when it comes to my choice, I know I will never get the in-depth coverage from any other channel except PBS.